Hello, ladies and gentlemen. This is some practice with balancing equations. I thought we'd do some online here. So this first one here, sodium plus oxygen gives you sodium oxide. The most basic way when you're doing equations is to start by balancing out your atoms. So I've got sodium, got one of them, got two oxygens. On this side over here, I have two sodiums, only one oxygen. So you multiply what you need. So you have a 1 over here. I got to multiply it by something to get 2. Well, anything times 1 is 2. So I need 2, a coefficient of 2, in front of that one there. Then if I had oxygen, I've got 2 on this side, only 1 on that side. So that would make this a 2. Those are next to balance, but my oxygens aren't right. So I've got 2 here, 1 there. I've got to multiply this side by 2, which does give me the 2 oxygens, but now I've got 2 times 2, so I actually have 4 sodiums. So what I have to do is go back and make this a 4. 4 sodiums plus oxygen gives you 2 sodium oxides. This needs times 2. Hydrogen plus oxygen yields water. Well, I like to start with my oxygens first, so I've got 2 oxygens on this side, 1 over here. I've got hydrogen, I've got 2 there, I've got 2 here. Well, that's nice, but that doesn't get us done. So since I have 2 on this side, I've got to multiply this by 2 to get 2. So I put a 2, or a coefficient of 2. So that's 2 times 1 now gives me 2. But 2 times 2 makes this 4. I only have 2 on this side. What can I multiply 2 by to get 4? That should be 2. So 2 times 2, this one is now 4. And that is now balanced. Sodium sulfate plus calcium chloride gives you calcium sulfate plus sodium chloride. What's nice about this sulfate, you can treat this as one atom when you're balancing it, called a polyatomic ion. So I've got 2 chlorines here, 1 calcium. I've got 2 sodiums over here. There's my 1 calcium, so those are okay. Here's my sodium. I've only got 1 of those. I've got 2 chlorines. I've got a sulfate on one side and sulfate on the other, which is actually good. The sulfate balances out that whole piece. So I need 2 chlorines, so I need to put a 2 right here. So that will balance out my chlorines. I only have 1 on this side anyhow, so I now have 2 chlorines there. But I have to multiply my sodium times 2. 2 times 1 is now 2, which ironically I have 2 on the other side. And that is all it takes to balance that one, because I have 2 sodiums, 2 sodiums. I now have 2 chlorines, 2 chlorines there, 1 calcium, 1 sulfate polyatomic ion. This is aluminum oxide that yields aluminum plus oxygen. I've got 2 aluminum here. Oxygen has 3 of them. On this side, I've only got 1 aluminum, and I've got 2 oxygen. So if we work on our oxygen first, and it's not a general rule, but when you can balance the oxygens first, it does make everything else kind of balance out easier. So 3 and 2. Well, there's nothing easy that 3 and 2 go into. What is the number that 3 and 2 go into evenly? Well, 3 and 2 go into 6. So I need to end up with 6 of each of these. So if I have 3, what can I multiply 3 by to get 6? That's right, 2. If I've got 2 on this side, what can I multiply 2 by to get 6? I got to multiply that by 3. So I go up here and I start putting in my coefficients of, there's my 2, because that'll give me 6 oxygens. 3 times 2 will give me 6 oxygens. So I have 2 aluminums right here, times 2. Technically, I have 4 aluminums on this side. This aluminum is all by itself. It has a number of 1. What times 1 is 4? Well, 4, so I put my 4 in there, and now that one is balanced as well. All right, last but not least, this is ammonia down here. So I've got nitrogen 1, hydrogen 3. Over here I've got nitrogen 2, hydrogen 2. So we need a number that 2 and 3 go into. Obviously, just like the last one, it's 6. So I need 6 hydrogens here. So I've got 3 here. I can put a coefficient of 2. 2 times 3 will give me 6. I've got 2 here. 2 times 3 will give me 6. So my hydrogens are now balanced. So 2 times 1 gives me 2. And ironically, I already have 2 on the other side. That one is now balanced. So I'm just kicking these out there to show you the basis of how we balance equations. I know there are more advanced ways using oxidation numbers, but for our purposes, this is going to get you as far as you need to go. And I hope this is helpful. Mr. Escock signing out.